When you step into the Oregon Vortex, the first thing you notice is how quickly your senses start to argue with each other. A simple wooden platform sits in front of you, and it looks normal at a glance. But the moment someone walks from one side to the other, their height seems to change right in front of your eyes. It's not dramatic or theatrical. It's subtle enough to feel believable, and that makes it even more unsettling. You watch the shift happen again. A person looks shorter on one side of the platform and noticeably taller on the other. There's no pause for explanation. The illusion hits before you even have a chance to prepare for it. Your brain tries to make sense of the scene, but something about the environment refuses to cooperate. This is the Oregon Vortex, one of the most confusing roadside locations in the United States. Here, balance feels slightly off. Objects appear to move in ways they shouldn't, and your sense of scale becomes unreliable within seconds. Some visitors believe the land has unusual physical properties. Others say it's all clever design. But whatever the cause, one thing becomes clear fast. Your eyes are not giving you the full truth. Thanks for coming back to Hidden Science. Today we're taking a closer look at a place where simple observations can make you question how your own perception works. The Oregon Vortex has been promoted for decades as a location where gravity acts strangely. Objects behave unpredictably, and people appear to change size in plain view. Many visitors walk in expecting a curious stop on a road trip and leave with a feeling that something didn't match the rules they learned in school. This episode has one goal: to understand what's actually happening here. Not through dramatic claims and not through dismissive answers, but by examining the experience step by step. We'll look at the history of the site, the demonstrations that made it famous, and the scientific principles that may explain each effect. And if some parts don't fit neatly into one explanation, we'll talk about that too. So let's start from the beginning and see why this small patch of land in Oregon has managed to confuse so many people for so long. Before we dig into the details, here's a clear overview of what we're going to explore. Understanding the Oregon Vortex requires looking at the experience from several angles, because no single explanation captures everything people report. So this episode will move through each part in a logical order. First, we'll look at the history of the site and how it became known as a place where physics seems to behave differently. Then we'll walk through the key demonstrations that visitors see: the shifting height effect, strange balance sensations, and objects that appear to defy gravity. After that, we'll examine what scientific measurements can tell us. We'll review magnetometer and gravimeter readings to see whether the land shows any unusual physical properties. We'll also break down how human perception works in tilted environments and why the brain can misjudge scale, direction, and balance so easily. Finally, we'll compare the Oregon Vortex to other well-known mystery spots and end by summarizing why these effects feel so convincing. To understand why the Oregon Vortex became such a long-lasting attraction, we need to look at how the story began. The site sits near Gold Hill, Oregon, in an area that was once part of a mining operation in the early 1900s. The old building on the property, known today as the House of Mystery, originally served as a small assay office. Over time, the structure started to slip and tilt due to unstable ground beneath it. The slanted interior eventually became the foundation for many of the optical effects visitors see today. In the 1930s, a man named John Litster began studying the site. Litster had a background in physics, and he believed the land showed unusual forces that affected balance, direction, and size perception. He spent years documenting what he thought were real physical anomalies, then opened the area to the public as a scientific curiosity. Whether or not his interpretations were accurate, his approach gave the place a sense of legitimacy. Visitors weren't told it was magic. They were told it was a natural phenomenon worth investigating. Throughout the mid-1900s, roadside attractions became popular across the United States. Families traveled by car more often, and small towns created unique stops to draw tourists. The Oregon Vortex fit perfectly into that trend. Its simple demonstrations made people talk, and word of mouth became one of its strongest promotional tools. By the 1950s and 60s, the site had established its identity as a gravity mystery, even though the explanations remained unclear. Guides continued to frame the experience as something science had not yet fully explained. That approach created a balance between skepticism and belief, making the attraction appealing to both curious travelers and people who enjoy unusual experiences. Today, the Oregon Vortex still uses elements from Litster's original presentations. The story has shifted over time, but the core idea remains the same. Something about this small patch of land feels off, and people come to see whether they can trust their own senses inside it. Walking through the Oregon Vortex feels like entering a space where familiar rules quietly shift. The demonstrations are simple, but each one is designed to challenge your sense of what should happen in a normal, physical environment. The first and most well-known is the height change effect. Two people stand on opposite ends of a wooden platform. Without any steps or props, they appear noticeably different in height. When they switch places, the difference reverses. It looks clean and direct, and the effect happens fast enough that your brain doesn't have time to settle on a clear explanation. Another demonstration involves a rubber ball placed on what appears to be a sloped board. The board looks like it's angled downward, but the ball rolls uphill. You instinctively look for hidden edges or magnets, yet everything is left in plain view. The board is light, the ball is simple, and the motion feels wrong because it contradicts what gravity should do in a space that seems level. Then there's the balancing broom. Guides place a broom on the floor, and it stands upright with little effort. In reality, a broom can balance on many flat surfaces, but inside the tilted environment, the effect feels more surprising. The uneven floor and skewed reference points make the balance seem unnatural, even if the physics behind it is normal. Visitors also notice their own bodies feel slightly unstable. When you stand inside the House of Mystery, you may lean forward more than expected without falling, or feel a sideways pull that doesn't match the direction of the slope. The tilt of the building disrupts the signals your brain uses to determine vertical alignment, and that confusion creates a sensation of imbalance. Although none of these demonstrations involve hidden machines or complex mechanics, they work because they combine visual cues, floor angles, and the brain's natural assumptions about straight lines. The environment is built in a way that removes reliable reference points. Without them, your perception becomes easy to manipulate, even when you think you're paying attention. Each demonstration is brief, but the sequence builds a stronger impression. By the time you've walked through all of them, the idea that something unusual is happening here feels convincing, and that feeling stays with you, even if you know there might be logical explanations waiting outside the boundaries of the vortex. To understand whether the Oregon Vortex shows any real physical anomalies, we need to look at measurements instead of impressions. The experience inside the attraction can feel strange, but feeling is not data. So the first step is checking whether the land shows unusual magnetic or gravitational behavior. If something in the environment truly pushes or pulls differently, the instruments should detect it. A magnetometer measures the strength and direction of Earth's magnetic field. In most locations, the field varies slightly from place to place, but only within predictable ranges. A gravimeter measures gravitational acceleration with extremely high sensitivity. If the ground had hidden density differences, or if there were a local gravitational disturbance, the readings would show it. These devices don't care about illusions. They only report numbers. When readings from the area surrounding the vortex are compared to readings inside the attraction, the results fall within the normal background levels for the region. The magnetic field in Oregon shows small variations depending on mineral content, but nothing outside the expected range. The gravimeter data is even less dramatic. it stays stable, with no measurable shifts that would support claims of altered gravity. If gravity were truly distorted enough to make objects roll uphill, or change someone's apparent height, the change would be enormous compared to what the instruments actually record. It's true that the land around Gold Hill includes fault lines and uneven terrain. Geological structure can influence local magnetic readings slightly, but the differences are too small to create visible physical disturbances. These variations are common across many parts of the western United States and do not produce the kinds of effects seen at the vortex. One important point is that the instruments measure the environment directly, while the human brain interprets the environment through assumptions, shortcuts, and visual patterns. When the readings show normal conditions, but the experience feels abnormal, the gap between the two becomes part of the story. The environment is not bending the rules of physics, it's bending your perception of them. Still, performing these measurements helps clarify what the vortex is not. There is no magnetic force pulling objects sideways. There is no gravitational anomaly lifting people or tilting their posture. The instruments confirm that the physical world behaves the same inside the vortex as it does outside. Whatever creates the unusual sensations comes from geometry and perception, not from hidden forces in the land. This makes the next step even more important. Understanding how the brain responds when it loses reliable reference points in a tilted space. When you step into a tilted environment, your brain begins fighting a quiet battle between what your eyes see and what your body feels. The Oregon Vortex takes advantage of this conflict. The effects aren't created by hidden machines or unknown forces. They come from the way human perception tries to make sense of uneven, distorted, or incomplete visual information. And once you understand how these illusions work, the entire place becomes a case study in how easily our senses can be pushed off balance. The strongest factor is the forced perspective effect. Your brain constantly estimates size and distance using familiar cues: straight lines, level floors, vertical walls, and stable horizons. When these elements are missing or tilted, the brain becomes unreliable. If the platform you're standing on slopes in one direction and the surrounding walls tilt in another, your brain still tries to interpret the scene as if everything is level. That assumption produces incorrect conclusions about height, distance, and alignment. The result is the height change effect that visitors find so surprising. Next is the tilted room effect, a well-documented illusion used in science museums and special exhibitions. When an entire structure leans at a consistent angle, your internal sense of vertical no longer matches physical vertical. The body responds by adjusting posture without your awareness. You may lean forward or sideways and still feel upright. Because your eyes frame the environment as normal, you trust the visual cues more than the signals from your inner ear. This mismatch creates the strange sensation of instability people report inside the vortex. Another key influence is the absence of reliable reference lines. Outdoors, the horizon is usually the clearest marker for orientation. Inside the vortex, it disappears. The slope of the ground, the tilt of the building, and the angle of the surrounding trees all conflict with each other. Without a consistent reference, the brain improvises. It chooses whatever line appears to make the most sense in the moment. That quick decision becomes the foundation for all the size and balance judgments that follow, even if the choice is wrong. Human perception also depends heavily on expected patterns. We assume floors are level. We assume walls are vertical. We assume people standing next to each other are influenced by the same orientation cues. When those assumptions break, the brain fills the gaps using shortcuts that normally work in everyday life. But in a distorted environment, those shortcuts create illusions instead of clarity. Research in visual psychology shows that once an expectation is established, the mind holds on to it, even when new information contradicts it. That's why visitors keep seeing the height difference, even after being told it's an illusion. Their brains cling to the interpretation that seems most stable inside the visual chaos. The final factor is sensory dominance. Vision usually overrides other senses, even when the other senses provide more accurate information. In the vortex, your body may feel the slope correctly, but your eyes anchor you to the tilted room's false geometry. Vision wins, and the illusion becomes convincing enough that you question your own stability. What makes the Oregon Vortex fascinating is not that physics fails here, but that our internal map of the world does. The space is designed, or has evolved, to expose the weaknesses in how the human mind handles orientation, scale, and direction. The laws of physics stay the same. It's our interpretation of them that bends. To understand why people consistently report height changes and balance shifts inside the Oregon Vortex, we need to test how perception reacts under controlled conditions. The goal isn't to replicate the attraction perfectly, but to isolate the psychological factors that influence what visitors think they're seeing. A simple experiment reveals how much expectation and suggestion shape the experience. The test begins with 2 participants standing on a platform built with a controlled 5-degree tilt. The environment is designed so that the tilt isn't obvious. Walls lean slightly, and the floor has an uneven visual pattern. Without describing the setup, the participants are asked to judge each other's height from left to right. Almost immediately, both people report a noticeable difference, even though the actual height shift is unchanged. Their perception adjusts to the slanted environment, and the brain quietly compensates by redefining what level and upright mean inside the space. A second phase of the experiment introduces suggestion. Before repeating the test, participants are told that many people see dramatic height changes under these conditions. With that simple prompt, their estimates become more extreme. They begin describing shifts of several inches, even though precise measurements show no actual difference. This demonstrates how expectation amplifies visual illusions. Once the idea is planted, the brain looks for evidence that supports it. A third test removes suggestion entirely. Participants are told nothing about illusions. They are simply asked to stand on different points inside the tilted room and describe any sensations. Many report feeling pulled sideways or leaning more than they expected. These sensations come from the conflict between visual cues and the inner ear's sense of balance. The effect is subtle but consistent. All 3 phases lead to the same conclusion. The mind adapts quickly to false geometry, and once that adaptation occurs, perception becomes unreliable. The experience feels real because the brain isn't faking anything. It's working with the information it has, even if the information is misleading. This is why the Oregon Vortex feels convincing. Visitors aren't pretending. Their senses are responding exactly the way human senses respond in distorted environments. And the illusion becomes stronger when expectations shape the outcome. The Oregon Vortex isn't the only place in the United States where visitors report height changes, strange balance sensations, and objects rolling in unexpected directions. Several mystery spots across the country create nearly identical effects, and comparing them reveals a pattern that helps explain what's happening in Oregon. One of the most well-known examples is the mystery spot in Santa Cruz, California. It opened in 1939 and quickly gained attention for demonstrations that look almost the same as those in Oregon. Visitors appear to shrink and grow depending on where they stand. Balls roll uphill. People struggle to keep their balance inside a tilted cabin. The entire experience relies on the same combination of slanted architecture and distorted visual references. Guides present the effects with enthusiasm, but the core illusions match those found in Oregon. Another example is Mystery Hill in North Carolina, which uses a similar setup: a cabin built at a steep angle, a viewing platform that exaggerates height differences, and outdoor areas arranged so that natural reference lines are hidden. When people walk through these spaces, their brains rely on the tilted structure instead of the true horizon. Even without knowing the details, visitors describe sensations that mirror the Oregon Vortex almost perfectly. These attractions were developed during the same era, when roadside tourism was booming and families looked for unusual places to visit. Many adopted the slanted room design because the illusions were reliable, inexpensive to build, and impressive for audiences of all ages. The consistency across locations is important. If multiple sites produce the same effects using similar architecture, then the explanation is rooted in perception and geometry, rather than in unique physical forces tied to one specific patch of land. This comparison doesn't take away from the appeal of the Oregon Vortex. Instead, it clarifies why the experience feels so convincing. The environment is crafted, or has shifted over time, into a space where the human brain can't correctly judge height, alignment, or direction. The same illusions seen in Santa Cruz and North Carolina appear here because they rely on universal features of human perception, not on rare geological anomalies. When you talk to people connected to the Oregon Vortex, you hear two very different perspectives. Each side believes its interpretation makes the most sense, and both viewpoints help explain why the site has remained interesting for so many years. From the guide's point of view, the vortex is a place where the environment behaves in ways that feel unusual, even after repeated demonstrations. Guides see the reactions of visitors every day. They watch people step onto the platform, notice the height change, and struggle to explain why it looks so direct. They watch objects roll in unexpected directions and hear visitors insist that something about the space feels different. Guides view these reactions as evidence that the land itself has distinctive qualities that shape the experience. Their belief isn't based on complicated theories. It's based on what they see people go through repeatedly. On the other side is the scientific explanation. When researchers look at the same demonstrations, they see geometry, not anomalies. They focus on the tilt of the ground, the angle of the building, and the missing horizon lines. They explain that the brain recalibrates inside distorted spaces, and once orientation shifts, everything else follows. A scientist points out that if gravity truly behaved differently in the vortex, precise instruments would detect it without any doubt. But the readings stay normal, which means the laws of physics never change. The experience does, but only for the viewer. What makes this contrast valuable is that neither side dismisses the experience itself. Scientists don't claim visitors are imagining things. Guides don't claim they've discovered unknown forces. Both agree the sensations feel real. The disagreement lies in the cause. One sees a physical mystery. The other sees a perceptual one. This difference highlights an important idea. You can have an intense, convincing, and memorable experience without stepping outside the boundaries of known science. The Oregon Vortex becomes more interesting, not less, when you view it through both lenses. One offers the story that draws people in. The other offers the explanation that makes sense of it. When you look at all the demonstrations together, a clear pattern forms. Nothing inside the Oregon Vortex breaks the laws of physics. Instead, the environment disrupts the cues your brain normally relies on to interpret size, direction, and balance. The effects feel strong because they take advantage of several weaknesses in human perception at the same time. The slanted floors and tilted walls shift your internal sense of vertical. Once that shift happens, your brain recalibrates and accepts the new environment as stable, even though it isn't. That change influences every judgment you make. A person standing a few feet away suddenly looks taller or shorter because your brain is working with a distorted frame of reference. The rolling ball demonstration works for the same reason. The board appears to be angled one way, but the true slope goes in the opposite direction. Without a reliable horizon, your brain guesses wrong. The motion looks impossible, but it follows gravity perfectly once the orientation is understood. Balance sensations also become misleading. Your inner ear senses one direction of tilt, while your eyes insist on another. That conflict creates the slight feeling of being pulled or leaning, even though your body is simply adjusting to inconsistent information. Suggestion adds another layer. When visitors expect to see something unusual, their brains amplify small differences and fill in missing details. This doesn't make the experience fake, it makes it human. The mind tries to build a stable picture from unstable cues, and the gaps become illusions. The Oregon Vortex feels convincing because it places you in a space where your senses stop agreeing with each other. When the environment pushes your perception off its normal path, the world seems to behave differently, even when physics stays exactly the same. The Oregon Vortex works because it exposes a simple truth. Our senses are not as reliable as we think. When the environment removes the cues we depend on, level floors, straight walls, and a stable horizon, our perception drifts without warning. The experience feels strange because the brain tries to build order from information that no longer fits. And even when we understand the science, the illusions still feel convincing. Knowledge doesn't always override instinct. This raises a larger question. How often do we trust what we see without considering how the environment shapes our perception? The vortex is an extreme example, but the same principles show up in everyday life. Small shifts in context can change how we judge size, distance, or motion. We often don't notice the change because the brain hides the uncertainty. So here's the challenge. Pay attention the next time something looks off in your daily environment. Ask yourself whether the scene is unusual or whether your perception is reacting to incomplete cues. The more you understand how easily the mind can be guided, the more clearly you'll see the world around you. If you found this breakdown helpful, make sure to like the video so more people can discover it. And if you want to follow future investigations into places where science and perception collide, hit subscribe so you don't miss the next episode. I'd also like to hear from you. Tell me in the comments which mystery spot or unusual scientific claim you want this channel to explore next. Your suggestions help shape upcoming episodes, and they often lead to some of the most interesting topics we cover. Thanks for watching, and I'll see you in the next one.